Okay, good afternoon and good morning to everyone, and welcome to this seminar on the impact of AI in education. This is part of the work in the Brazilian-Sweden working group on AI automation and digitalization. This is a collaboration between Brazil and Sweden. My name is Fredrik Heinz. I'm a professor of computer science here at Linköping University, and I'm the Swedish chair of this working group. And today I have the great pleasure of welcoming you all to this event. We will have two sessions. The first session will be Landscape of Education and AI in Brazil and Sweden, and it will be chaired by Professor Cesar Marcondes. And then we will have the second hour. We will talk about learning analytics and gamification to empower education. With that very short introduction, I would leave the floor to Professor Cesar Marcondes to lead the first hour. Cesar, please.
Hi, everyone. Let me put me in the spot.
Yeah, I would.
All right, very good. Hi, everyone. I'm Cesar Marcondes. I'm professor from Aeronautics Institute of Technology, ITA, in Brazil. And today we're very glad that we're going to present this webinar on impact of AI in education. The first session will be on landscape of education AI in Brazil and Sweden. And we have a very interesting talks from Professor Seiji Isotani from USP, Harvard, and also from Professor Fredrik Heinz from Linköping University. So let's please, start with Professor Seiji. That's going to discuss the AI education projects evolution in Brazil. Seiji, you can start.
Yes. Hi, everyone. It's a pleasure to be with you today. So, what I'm trying to do here is just to present one case of how we can use AI for education together with public policies here in Brazil. But before presenting my work or my team's work, I want to acknowledge them. So the first thing is, oh, what happened? Okay, some problem happens. Let's see if we can try again. I'm sorry, technical problems. Okay, hopefully you can see me. And now I don't want, for some reason. Okay, now it seems to be.
Yeah, it worked. Appear to people.
Showing to people. Okay, nice. So first I want to acknowledge the team that has been working with me for so many years. So the work I'm going to present is not my work, it's their work. And together we call our team NIS, so Center for Excellence in Social Technologies. And we are not just at USP, so in Brazil, so we are an association of several researchers across Brazil. So we usually say that whenever any place you go, probably you'll find someone from NIS around Brazil. And we are also collaborating with several different institutions around the globe. And hopefully we can put another pin with Sweden maybe in the future. All right. So what we try to do is provide evidence about AI in education, try to design and implement public policies to support governments to run their policies, and finally support capacity building. So this is the three main pillars of our work. And as of today, we serve like millions of students, thousands of teachers, published several papers, and we are trying to support governments in several different ways. All right. So when we are thinking about AI and public policy, so we have several different benefits. And so we can have different kinds of technologies to support augmented teaching and learning, co-construction of knowledge, content recommendation, and so on. But the challenge we are considering now is, especially here in Brazil, is that AI is becoming a new source of education inequality. So the more we see, the stronger the inequality becomes. And the challenge for us is to think about ways of overcoming this problem. Just to make it more clear, so if we look into the economies, so you have in red dots here, the advanced economies here. We have the emerging economies in blue here in the middle, and we have the low-income countries at the bottom. And the advanced economies, they are prepared to use AI as well as they are exposed in terms of employment. And the emerging economies, they are somewhat in the middle here. Brazil is around here in the middle, but most of Brazil, if we think in terms of overall population, we are here in low income. And the challenge for us is, okay, so how can we look into this population and provide technologies, or especially AI technologies, to support those populations? So the question our group tries to answer is, how can we bring the benefits of AI to people and places where technology and infrastructure are not available or almost not available? So that's the question we wake up every morning and try to tackle. And for us, what we need to do is, instead of going with current AI technology, is thinking about different ways so we can produce emerging technologies. So at the end of the day, we can have higher impact in less time. So that's the idea. And to do that, we are trying to rethink how we design AI technology so we can actually reach those populations. And 2 years ago, we proposed the idea of AI Unplugged. And I'm going to try to present to you the main ideas of this way of designing technology for resource constrained environments. So the first one is in terms of conformity. So instead of trying to go there and change infrastructure, so we should consider to use the available infrastructure. So we are thinking about places like these ones. So this is a city. It's called Abaré in Brazil, and this is the 10 years ago where we went there, is the infrastructure that the city has. So, and here is Amazonas, so where Elaine comes from, and several students go to these schools. And if you see like this classroom here, at the bottom here is water. So when the tides goes up, so the other water comes up, and then when tides go down, so the water is around here. And as you can see, we already have some kind of technology here, because most teachers here in the capital and they cannot go to those places. So we need some kind of way of allowing teachers to actually teach those students. And the question we had is, okay, so what kind of technologies we have there? And by looking to some different types of data, we check that cell phone subscriptions, even in low-income communities like in Brazil or any other country, around 90%, even like in 2022, around 90% of the population has access to cell phones, which is one kind of infrastructure, right? So having a cell phone nearby is one type of infrastructure that we can use. And then we can think about internet. So instead of trying just to putting internet everywhere, so we can also think about nowadays, is internet available? And then we have a different story here. So low-income communities, around 50% of them have access to stable internet as we are using right now. So the challenge here is it will take almost 100 years. This is the analysis that we've done. So we've done a regression, and we show that it's going to take 100 years to fill the gap between low and high income communities. So this is a big problem for us. So if we are trying to use internet or any kind of technology that use stable internet or synchronous interaction, then we are going to have a problem for this population. We also are looking to people who have access to the technology that can benefit other people as well. So when we are thinking about AI technology, it's if our target students, maybe we can create technologies to augment the capabilities of teachers so that teachers can better interact with students. So in that way, we have a cycle where we can actually reach to or impact the more number of students with more benefits. And finally, thinking about multi-user capabilities. So imagine trying to personalize learning in a classroom like this. Usually in technologies that we frequently use, we ask, for example, students to use a login and password. For this case, it's unbearable, unimaginable to ask for students to for a login and password. So in that way, how we can design personalized learning considering this kind of situation. And finally, just thinking that if we can create technologies that do not require additional digital skills, then we have a much better chance to support people to use those kind of AI technologies. All right, so how we can use those ideas to change a public policy and design new technologies. One of the policies that we've worked in Brazil was to improve writing skills of students after the pandemic. So students in the 5th, 6th grade, they kind of lost their ability to write because they spent almost 2 years without writing. And government asked us to, okay, so let's try to create a solution that help those students, but also consider the social inequalities of the country. And the previous solutions before we start working with government on the solution was, okay, so students, to help students to improve their writing skills. So we need to ask them to write essays. And those essays would be mailed, like physically mailed to a university in Brazil. And this university would do like a peer review. So they will ask students to review those essays. So students, undergrad students to review those essays, and then return the essays to the back to the schools. And the challenge for this in terms of learning is the time. So usually it would take 4 to 6 months to receive a feedback. So if you are thinking about helping students to write, this amount of time is too much. So they are doing something else during this period. So the idea is how we can propose a better solution. So the first one is trying to understand where we are gonna, the vision that we wanna work with this particular technology. So instead of thinking about the infrastructure we need. This is the foreign balance model. So we go from the division, and then we train a personnel, design materials, and then if needed, we work with the infrastructure. So we try to identify several different problems and causes for the low performance in text writing, and we identify that teachers overload is one of the challenges, and how we can empower teachers at the same time that we do not ask them to do more stuff. So what we've done is, okay, so let's create this application where we use their cell phone to take a picture of the essay and then analyze it when internet is available. So what happens is, okay, we ask anyone, the students write an essay, we take a picture. Whenever internet is available, it doesn't need to be available every time, but whenever internet is available, we can send this photo to our server, and we process, and then we return a feedback to teachers. So for example, this is one picture of an essay. This is another pictures. So you can see different ways of writing, different ways of taking pictures. So this is another one. And what we do is, okay, so we can extract the text from the sheet of paper, and then we do the segmentation of lines, the segmentation of words, and then finally, what we develop is this dashboard where the teachers, I'm sorry, it's in Portuguese, but the teachers can check different information related to the essay. For example, this is formal writing, this is coherence, cohesion, and typology. And we can see where students are getting good marks and where they need to improve. And we can do this for one particular student, for a particular class, for the school, and so on. So we can aggregate in different ways. So for example, here in cohesion, there is the semantic logic link is something that needs to improve for these students in 6th grade. All right, so at the end of the day, the cycle that we have is this one. Right? Take a picture and do the analysis, and we check. We have a dashboard, and we can provide feedback to teachers and hopefully to students in the near future as well. So just to summarize, we run this approach with 7,000 schools, more than 1,500 municipalities, 500,000 students, and 20,000 teachers. And the results that we got is, okay, the first one is who were using the technology. We didn't impose the use of technology, so it was a policy, so anyone in the country could use it if they wanted to. And we observed that the poorest regions in Brazil were the ones who downloaded and used this technology the most. So this is the first thing, which is pretty interesting to us. And then in terms of learning, so we ran an impact analysis with a set of the students, and we observe gains in terms of learning, as well as we compare inequalities considering two variables. The first one is boys and girls. The second one is rural and urban schools. And we were able to see, for example, differences in female and male students. So the female students gain better skills and kept learning, while boys actually lose some after the fourth interaction, where we had to stop using due to government issues. And we see some trends, but not significant yet, between rural and urban schools. So we were able to see potential opportunities where rural areas can actually improve their students' learning. All right, so that's the ideas I want to present you. So thank you very much, Cesar, Frederick, for the invitation, and I return the floor to you. Thank you.
Yeah, perfect, Seiji. Very, very thoughtful. Let's pass on to Professor Frederick Heinz from Linköping University. Please, Professor.
Thank you very much. Let's see. So now I think you should be able to see my presentation. Okay, so good afternoon, good morning again, everyone. So it's a great pleasure to be able to present this national initiative. One of the programs that I lead is the WASP-Ed program, which is the Wallenberg AI and Transformative Technologies Education Development Program. So that is what I intend to present here. And basically, the overall purpose of this project is that we need to significantly increase the capability and the capacity of Swedish universities in providing timely, relevant, and scalable education in AI. And also that we want to achieve a national step change in both the quality and the quantity when it comes to competence in AI. And the focus on this program is higher education and professional development. So of course, then one can ask, why do you need such a program? And I think we have all seen these kind of studies where you're seeing, so this is a study of about 700 consultants from Boston Consulting Group, where they are comparing the consultants using AI compared to consultants not using AI. And they come to the conclusion that those consultants that are using AI tools, they're able to complete 12% more tasks in the same time. On average, each task is done 25% quicker, and they can also increase the average quality with 40%. So basically, by using AI tools such as ChatGPT and others, they're able to produce more, faster, and better results. And of course, this is likely to have a major impact on the future of work. I think a positive note is also that the consultants that had the most benefit out of this were the junior consultants, which were then able to take on more challenging tasks that previously would have required a more senior consultant. So I think we really showed, and this shows that we're raising the lower level and really empowering people to do more. But it's not only work, it's also, of course, education. So, I mean, I think this is a pretty old, and I mean, you probably can question this particular study quite a lot, but the point is still that if you're looking at particular education programs, if you're looking especially at examination, what you often find is that the kind of current AI tools are actually very good in completing the kind of exercises, the kind of tasks that we give to our students. So this particular study argues that GPT-4 was better than the average law student at this British law program. And so what can we learn from this? So I think a number of observations is that first of all, probably very few, if any, would replace their legal team with, say, GPT-4. At least I hope not. But it also shows that what we examine and how we examine probably can be improved because at least in Sweden, the trend is that we should make the descriptions of the examination and description of what exactly the students need to know more and more specific. But then we have this interesting effect that the more detailed, the more specific we make these instructions, the easier it will be to automate and to basically replace the learning of the students with just nothing. And so, it will have a profound impact on education as well. So that's somewhat of the background. And I think we can identify a number of characteristics of the type of transformative technologies that we are looking at. And that is, we see a rapid increase in demand for this technical competence. So we need to on a short notice, increase the volume significantly. But we also see, and I think this is much more challenging and much more important actually, and that we see a broadening the demand and scope to other subjects and professions. So basically today, lawyers, medical doctors, HR people, economists, journalists, and so on and so forth, they also need to know how does AI impact my particular profession. We're also seeing now, of course, the impact on AI on science, with two of the Nobel Prizes awarded, both in physics and chemistry, basically in the first case, more the development of AI technology itself, but the second one in chemistry, it's really about building AI tools to help scientists do better research. So, I think we will see a major impact also on science. And lastly, we also see that the previously agreed subject matter content actually changes. So if you go back 10 years and you asked, what is the content of your introductory AI course? Almost every university was using the Russell and Norvig book, AI: A Modern Approach. And basically that was more or less the universally agreed upon content of most AI courses. Of course, there are a few other books, but that had a major influence. But today what we see is that people teach and what they include is much, much, much more varied than it used to be. So these in some sense are three of the challenges that we wish to address. So what we want to achieve is to reach a commonly agreed subject matter content. We want to introduce AI in education beyond the kind of specialized kind of technical education, which we already know how to do. And we also need to increase the teaching capacity in order to scale up the competence. So that's basically the four things. We want to provide educational foundations, scale up national capacity, scale out to more disciplines and professions. And we also want to actually use these kind of tools on education and pedagogical transformation, which Teresa will also talk more about later. So since we designed this to be a research program rather than to be a research project, what we have done is to define 6 work areas, which then covers all these different topics that we are interested in. So we basically have the 3 blue ones are related to more the kind of content of education. So there we have curriculum development, we have program development, and we have course development. And then we have the green ones, which are then more kind of supporting. So there we have this pedagogical development and learning analytics. We also have a work area around technical platforms and educational data, which if you want to work with, say, learning analytics, actually is one of the kind of challenges to get access to high quality data. And finally, we also have a work area around teaching competence development. So in order to be able to increase the national capacity, we need to teach the teachers about AI. And then, so we have each of these work areas then led by two people from different universities. So this is really a national research program to really make a difference. So and to kind of position this research program in the kind of ecosystem. What I see our role is really to bridge between research and innovation and deployment. So of course, we have, so the question is basically, how can we take the research and what we have learned from research and quicker get it out into the innovation and deployment ecosystem? By kind of bridging this and through higher education supporting this connection. And actually in Sweden, we have several major basic research programs. So the largest one and the ones that I'm involved in is the WASP program, the Wallenberg AI Autonomous Systems and Software program, which is Sweden's largest research program. So we have a funding of about 6 billion Swedish kroners, which is about 600 million US dollars over 15 years. And the goal is to educate at least 600 PhDs in the areas of AI, autonomous systems, and software. Currently, we have educated 140 have defended their thesis. We have another 450 or so in the research program, and so probably we'll most likely have about 700 or 800 PhDs coming out of this program. We're also doing international recruitment. So the overall goal is really to do the basic research today that's needed in order to secure the competitiveness of Swedish industry in the future, but also to support society. So there are this kind of basic research program, and then this WASP Ed program is basically an addition on that to accelerate the uptake of this, what we learned through the research, and to bring that more to the innovation and deployment part. So if we then look at the different work areas, the first work area is on curriculum development. So there we have been doing an inventory of different AI topics, programs, and courses in Sweden. We have also started to map out the programs and courses into a holistic AI curriculum. So actually what we have also done is that we have tried to identify and to develop a new curriculum for AI. And curriculum here should be interpreted in the sense of the ACM computer science curriculum. So it's not a curriculum for one particular program, but rather what does this subject contain? And then you will have to make selections of this broad and vast area in order to be able to design particular programs or courses for that matter. So what we have done is that we have taken the kind of core AI functionality, I mean, the kind of technical content, the kind of content that you see being presented at AAAI, HCI, NeurIPS, ICML, and so on, the kind of core technical content of this, that's this layer 1A in the upper left. But then we also need to be able to build these AI systems to interact and collaborate with humans. So then the next layer is really this human AI collaboration part. Then the third layer is now we take a societal perspective. Then we need to consider this kind of ethical, legal, social, economical, and cultural aspects of AI. And in Europe, of course, we have this concept of trustworthy AI, which we would also consider to be more on this society level. And then we made a difference between more the kind of software related part and the kind of more hardware or physically related part. So there we have more the robotics and so on. And then you need to apply this either towards research or towards society, which then of course includes both the public and the private sector. And then you can study AI as a subject and so on. So we're trying to describe and to capture what we believe this new subject to contain. If we're then looking at the work area 2 on program development. What we there are looking into is how can we design new education programs where AI is added on to or integrated into a kind of an existing topic or area. So here we've been looking into medical education programs and how can we integrate AI into those medical programs. So there we have a number of different universities working together to try to identify how should we work on this. And actually, if I take Linköping University as example, actually our rector has said that he wants AI to be part of every education program at the university. And now we're trying to figure out how to actually do that. When it comes to the program development part, here we're very much interested in defining and working out new ways of delivering courses. So one thing we have been doing is this elements of AI. So it's this Finnish open online course that we have been bringing into Sweden, and we have translated that to Swedish. And there we have almost 80,000 people part of this course, and we have more than 10,000 people receiving university credits for a course. And considering Sweden is much smaller than Brazil, so that's actually 0.1% of the Swedish population have received university credits from this particular course. And what we are doing there is that we're continuous acceptance and admission and continuous examination. So basically running a course all the time. But we also have another initiative where we're working on progression between universities. So that the first part of the course is given at Lund University in the south. Then the second part of the course is given by Uppsala, kind of in the middle. And then you have the third part given by Umeå University further up north. And then trying to figure out how would it work to have a progression, not within the same university, but having progression between universities. So really trying to figure out all the nooks and crannies that you need to do for that. When it comes to this pedagogical transformation and learning analytics, actually, I think better to let Teresa talk about that later on because she will be talking about some of the work that they have been doing there. But basically there we're looking into how can we use this kind of learning analytics, but also trying to understand how is the adoption of this and what is the view on generative AI for higher education, and also developing guiding frameworks for supporting this. We also have the fifth work areas on the infrastructure, technical infrastructure and educational data. So there we have been doing a survey of what are all the different systems, what are the infrastructure that the universities are currently working on using, and trying to understand the similarities and so on. But because what we want to do is, of course, to understand if we want to collaborate more between the universities, then we need to have some form of common platform. What would that common platform look like, or how should we support this kind of seamless transfer of either courses or results and so on between the universities? So I think this is very challenging, but also very important, especially if one wants to do more collaborative work. When it comes to the teacher competence development, we have developed 5 different modules with teaching material. So basically developing material for pedagogical development units at the universities, which are then normally responsible for providing competence development for the teachers. We're also working with a national network with representatives of the pedagogical development of higher education from these different universities. So we're also spreading how best practices around teacher competence development. We have also developed an open online course that's currently available at Linköping University. It's now given to all staff at the university to learn. So it's called AI at Work to help them use this. And actually, we have made Microsoft Copilot available to all staff and all students at the university so that they can use these kind of tools. So to summarize, so this is a national research program on increasing the Swedish capacity for transformation when it comes to AI and higher education. It's actually not that much funding, so it's 1.6 million US dollars, something like that. So, but really about working together, which I really think is the key term here. I actually had something about the kind of future. So just very, very quickly, actually, we have had a number of studies in Sweden from the kind of authorities for higher education, for example. And basically, the conclusion is that they all agree that AI will have a significant impact on the education. We need to increase the flexibility of our educational system, and we also need to take this kind of systemic perspective on things. Because I think AI will really be a powerful tools that will be used by many professions. We probably will see more automation. And I think one of the changes here would be that we need to be better at asking questions and verifying answers rather than providing the answers. And if we look at traditional teaching, it's very much about the teacher asks the questions, the students answers the question, and then the teacher verifies the answer and then provide feedback. And maybe we need to flip things around and think maybe we should actually kind of do the other way around, or at least work more on these other things. Because I think what we need to teach the kids and people in general is that how do we deal with this much more complex, imprecise, multifaceted, uncertain, and wicked problem? Because I think that is what we really need to figure out and what we need to focus on. I think we need to focus on AI literacy because everyone needs to know how can I be a responsible and critical user of AI technology. So actually, we have a number of research projects related to that as well. And we also need to understand how does AI impact different professions and subjects. And we need to prepare people for this kind of AI plus human kind of Kantar future. So some things I think we need to work more with the data-driven mindset, computation-driven mindset, Kantar mindset, working together with these tools. And to conclude, I mean, I think there are so many stimulating and interesting research questions related to this. So, for example, what does everyone need to know about AI? So, what is the kind of content of this AI literacy? How would you teach it? What does this specific professions need to know? So if I'm working with, say, occupational therapists, just to take one particular program that we have, what do they need to know? Or the journalists, what do the journalists needs to know? And I think there's so much in this kind of in between different subjects. How do we integrate AI into existing education programs? Because I don't think there's any point in just adding a new subject or a new course. Now you introduce an AI course in every program. I don't think that will really make a difference. Of course, well, they would learn a bit, but to really get the effect, you need to integrate the use of AI tools into the rest of the education program. At least that's our experience when we worked with programming. How do we teach AI to new groups of students? I mean, we had the previous presentation, I think was a great example. I mean, how do we actually make this kind of technology available to areas and places where it's very difficult to get access to this? So how do we scale up those kind of things? How do we combine learning and working? Because probably a lot of people will need to upskill. And in order to be able to upskill, they would not probably not be able to afford to be able to just leave their job, but rather they will need to do this while working. How do we support that? How should the educational system look in an AI-powered world? So, I mean, what are the other changes? Because, I mean, my expectation is probably might be more changes needed in order for the educational system to be relevant and really preparing people for the future. And, I mean, we all know that there's so much more to learn. So, can we actually accelerate learning? Can we help people learn more faster and better just to see the same results that we saw from these consultants? So these are some of the very interesting research challenges we are interested in working on going forward. So what I've tried to present here is both this kind of VASP-Ed program, a little bit about what we're currently doing, but also to look forward and see I mean, I think this would be a very interesting area to have more collaboration between Sweden and Brazil. Thank you very much.
Thank you very much, Professor Fred Keitz. Very interesting presentation. So in our seminar, The next part is going to be a short discussion and Q&A session. So I ask people from the audience that's watching us for questions, or we can either have questions from the panelists as well. So let's see. I have the first question. I can start for Professor Seiji. So Professor Seiji, you know that LLM models, or especially open source models, LLM open source models, they can be offline. Like I read some articles saying if you're in the end of the world situation, maybe it's a good idea to have like a LLM at your hand so that you can start over the civilization. Do you think about maybe have LLMs, open source LLMs, like in these communities or villages to maybe support these education things?
Sure. This is an interesting research pathway. So we are trying to, for example, test different equipments like cell phones, Raspberry Pi, and other technologies in terms of hardware, and put LLMs, different versions, for example, Tiny Llama and others, into those equipments and see how they interact or how they respond. So, for example, in cell phones, the response is not so good. So it takes several seconds, sometimes minutes, to have a response. The other problem is in terms of Portuguese versus English. When you ask in Portuguese and the response is in English, that is still okay. But if you ask these tiny LLMs to respond in Portuguese, that is no good. And they start to create words in Portuguese that doesn't exist. So it's really interesting to see like responses that you don't know what they mean. So it still is a challenge. If you have a how can I say, a robust computer, like a powerful computer that you can put in those places, I think it's not a problem. But if you're thinking of including LLMs into classrooms using cell phones, then we are still having some work to do, and we are trying to address this challenge, trying to create like hybrid infrastructure. For example, you have local networks, and this local network has a more powerful computer that has access to internet, for example. And so you can, for easy questions, you can just connect with the local network and get a response. And for harder questions, so you send it to the web and get the response. So we are testing these different kind of scenarios and see which one is better for learning in our case. So I think with this hybrid approach, maybe we are going to be able to actually give access and meaningful access to those regions. And if you think about these situations like the ones I showed, it's around 70% of the population of the world. So all the global south suffer the same problem. And if we can find solution for this problem, then it means that we can solve the problem for the more than 70% of the population that usually is left behind. So that's one of the works that we are doing.
All right. Thank you very much, Professor Seiji. I'm going to ask a question for Professor Frederick. How do you see the need sometimes for understanding AI of some basic linear algebra and other math subjects for people that are not in these areas?
So I think here we need to kind of differentiate between what are you going to use AI for. I mean, if you're actually going to develop, I mean, more technical solutions and developing new AI methods, maybe even, I mean, implementing them and so on, then I think you need, I mean, linear algebra to be able to understand the kind of mathematical foundations for say machine learning and so on. However, if you're say a lawyer then or a journalist who is going to understand AI and probably use it as a tool, I don't think you need to have that kind of technical understanding. I think there you need more the conceptual understanding of say how does a let's say a language model work so that you can actually understand why is it doing this kind of mistakes or issues that Seiji is mentioning that which we see. I mean, trying to why can that happen and so on. So I think there it's more to have this kind of conceptual understanding that should be sufficient. But then I think there's people that are kind of in between, and say for example, I'm a medical technology or trying to figure out what the name of them is. So maybe that you're doing lab analysis and then you're using like computer vision techniques to automatically analyze samples. And now the question is, I mean, you actually have quite a technical job, but now the question becomes how much do you need to understand? Do you need to understand, as you say, the kind of math behind this, or is it more enough to know that there are actually more different types of computer vision techniques or different ways to do this, which get different results. So I think I mean the first two categories are probably quite easy, but then I think there are also categories in between, which is much less clear what they actually need.
Many thanks, Professor Frederick. So we have a question from the audience, Michelle. Professor Seiji, in the example you described, is the grading process of submissions completely automated, or teachers are necessarily to read and grade them? However, they are supported with preliminary results. So is this a mixed or is it totally automated, I think?
Yeah, that's an interesting question. So in grading, the idea, we do not grade the essays. What we do is providing feedback for teachers about the how can I say, the quality of the essay in terms of different metrics and rubric. So in that way, our idea is not to assess student work in terms of grading, but rather give information for teachers to empower the teachers to be better teachers in terms to support students to write better. So that's our goal. So we could actually do the assessment and provide a grading. For example, I don't know, from 0 to 10, students got 7.3 or something, but we don't provide this number. What we do is information, and the teacher actually work with students. And usually for this particular purpose, teachers do not grade students. Teachers provide feedback to learning.
As a follow-up on this, Professor Seiji, do the automated system provide some recommendations of improvements, like in the text, for example?
For some reason, I think I lost my.
Yeah, sorry.
Okay, go ahead.
Yeah, I'm just saying, as a follow-up of that question, do the system provide like a recommendation of how to improve? Like, for example, this paragraph should have this verb or this, noun.
Right now, no. What we do is providing an overall overview of uh, the the potential problems that students are having when writing. We could highlight to teachers some passages. The challenge for highlighting means that we need to return all the essays back into the cell phone with the highlighting, and teachers would need to look into all of those. So if we do not want to increase the burden of teachers, then at least for that particular study, we haven't done that. But for other opportunities, I think would be really interesting, as you said, Cesar. So providing very specific feedback for teachers to actually look into students' passages and actually provide support for specific topics. So it's an interesting future work in that situation.
All right. So we have another question for Professor Frederick. What's the first discipline, study, subject where AI will be successfully implemented? Natural sciences, humanities, or social sciences, engineering?
Yeah, of course, it's challenging what means with successfully implement. But I mean, I would say the following. I mean, if you take engineering, which in some sense is, well, we mostly educate engineers here. I mean, I would say all of them are using machine learning in their kind of professions. So we really see that this has have had a major impact on engineering, that is used as a tool in many parts of the kind of engineering processes. So my guess would probably be engineering would be the first, but I mean, I think I think there's so many interesting things looking at social science, for example, and to do large scale analysis and experiments. And we're also seeing now that one could potentially replicate studies. So instead of asking people, you can have the kind of language models acting as if there are different types of kind of groups or and you can actually get similar results as when you do surveys on people. So I think it opens up a lot of very interesting things related to social sciences as well. But engineering, I would say, is the first.
Yeah, just as a complementary, here in our school, in our Aeronautics Institute of Technology, we have like 7 or 8 engineering schools, mechanics and electronics, and many of these are doing AI in some sense. I mean, we have been seeing lots of projects that are showing up at AI and mechanic engineering, aeronautics, and all that across. Yeah, very interesting. So there's another question from the whole panel. How agile do you believe higher education curricula is to adapt to fast development of AI, fast-paced development of AI? How will upskill those who need new skills? Anyone wants to go for this?
Yeah. I mean, so, I mean, if we look at how do we kind of approach this, because I mean, of course, take computer science as a discipline. I mean, there is so much going on all the time, but actually the kind of foundations are quite stable. Of course, there is new things being added, but it doesn't invalidate the kind of foundations of the subject. So I think that's one way to kind of make sure that the foundations are stable and that you cover them, and then that you have the kind of some freedom in adding and adapting so that you can include the kind of latest developments. So in that sense, I think we can deal with that.
You're mute, Seiji.
I'm sorry. Yes, it's a super interesting question. I have a few perceptions, not just in the field of computer science, but in general. So I was in the US teaching when ChatGPT arrived. So end of 2022, I was since the beginning of 2022 teaching, and what I've seen is after ChatGPT appeared and this boom of AI started, people in the grad school of education and the engineering school, they started to analyze how they can implement and use the impact of this technology on undergrad students. And we create several different working groups. So I participate in a working group in the grad school of education, in another working group that unites several different schools in Harvard, and discussing the role of AI in education for undergrad students and for the profession, different professions. And in less than 1 year, people were able to create like completely interactive AI assistants for support students. So this is one kind of use of AI inside of undergrad studies. And then people start to see how we can redesign the curriculum, thinking about the different uses of AI for design, for language learning, for technology and innovation, and so on. So what I'm seeing is, in a very short space, people were able to adapt and change really fast. And then I moved back to Brazil like 2 months ago. And what happened, what I saw here is people are, how can I say, they do not consider that much the use of AI for changing the curriculum. The teaching is the same, the curriculum is the same. People are talking and mocking about AI, so everything is still the same. In most of the curriculum that I'm seeing, so computer science, engineering, different kinds of engineering, so it's all the same. And the question for us is, especially in the STEM field, how challenging or how much change should we do? For example, computer science. If as Frederick presented, if the machine can do basic programming better than students, better than some professionals, so how can we actually teach these basic concepts, but actually move forward in a faster pace? I don't know what kind of changes actually we should make in terms of creating better, for example, computer science professionals that will be able to push forward our field. So that's it's still a question, and I really like the presentation of Frederick, because it provides us with some guidelines for us to like think ahead and move forward. But I'm still thinking about discipline by discipline or course by course. So how we should like move forward. So this is a big question. I don't know if Frederick has any other insights that he can provide to us.
So actually, I wanted to address the last question from Marco. So basically, how do we avoid a very shallow learning? Because actually, I think it also relates to the previous question here, namely that I think here we have a choice. So I mean, if you, as a student, say you get the question in a course or you get some assignment and you just plug it into your favorite AI tool, and then you get a response, and then you just submit the response to the teacher. Then, of course, you haven't learned anything. You have just copy and pasted things from one window to another. So of course, that's just a waste of time. But if you instead use the tool, maybe you have some initial thoughts, oh, maybe this is my kind of what I think the answer would be. And then you can get feedback from tools. Have you thought about this too? So I think there are this kind of what I think is called Socratic methods. So you can basically configure these kind of tools. So instead of giving you the answer, it will help you by giving you guiding questions to make you self answer the question. So I think here it depends very much on how we actually use the technology, and we can either use this in that we completely delegate the question or the task to the system, and we have absolutely no input, no added value, and then of course we will not learn anything. So the question is, how do we stimulate and how do we support this more constructive way of learning? And that I think is the key challenge and the way to avoid the situation that Marco mentioned is in his question. Mm.
Yeah, unfortunately, we have to move on. So thank you very much, Professor Seiji, Professor Frederick, for all the presentation and discussions. I leave it back to Professor Frederick to lead the next session.
Thank you very much, Professor Cesar. So now we will open the next part of this event. So our first speaker is Professor Elaine Herrada Teixeira de Oliveira from the Federal University of the Amazonas, who will be talking about learning analytics in introductory programming. Please, Professor Elaine, the floor is yours.
Just a moment. Thank you so much. Just looking for my screen. Just a moment, please. Here we go. Can you see it?
Yes.
Okay. Thank you so much for this invitation. It's really nice to be here. Just a little notice. Let me think a bit how I'm gonna say. I wasn't the first speaker for this meeting. So I'm not going to talk about gamification as the previous speaker. I'm going to talk about learning analytics in introductory programming. I come from a research group called Research Group on Computing Education at the Institute of Computing at the Federal University of Amazonas. It's called UFAM in the Amazon. Let's see if I can move on. Okay. I live here in Manaus by the Black River, and this is our campus in the middle of the forest. Okay, I'm going to talk about Computer Science 1, Introductory Programming, but as I was listening to the other talks, I was thinking that it could fit in like Introduction to AI, for example. So everything I'm going to talk here fits to an introductory course to AI, for example. But in our case, we do have large and heterogeneous classes. We have many students that struggle to learn how to program. So when I say, okay, some students come here and it's their first contact with programming like Python. It's the first contact with AI, for example. It's a mandatory course for non-CS courses. So some students come here and say, oh, why do I have to learn how to program? I'm not going to be a programmer. Why do I have to learn that? And we have high failure and dropout rates worldwide. It's like 50%. But at UFAM, we have like 50. I said 30%, and at UFAM, it's 50%. So it's a major issue, and we've been thinking about it for a while. And it's also common sense at computing education research that we learn programming by doing. So it's not enough just to listen to a talk, to see some videos. It's really required to do programming. So at UFAN, we work with 4 engines. So we have the online tools, and nowadays we use only one, that's an online judge that's self-devised here at UFAN. We use it to use Moodle, for example, but we don't use it anymore. We have some educational data that come from this online judge and from the institution, for example. And with that, we do some learning analytics that I'm going to show you later. With this, we try to predict, describe, intervene, recommend, customize learning for our students. And we also we use it to work with gamification, but we did a break with that. We just considering if it's worth it to invest some time on that. So we're having a break on that research, but we do have some results from that. So it's something that we should think. Okay, so in this talk, I'm going to talk about learning analytics. And I don't know if everyone is aware of this, but learning analytics is based on measuring, collecting, analyzing, and reporting learning data. So we can, what's the goal? To understand and optimize learning experience, the learning experience itself, and how it impacts the organization, the settings, and everything. It's a definition, it's a paraphrase from a definition that was coined by some researchers in the main venue, that's the LAC conference, and it was coined in 2011. Okay, I'm going to show you just a few screenshots from CodeBench. That's the tool that we developed. As I said, it's self-devised here at UFAN. So we have the instructions functions. Oh, and it's good to tell you that the main leader of this project is Professor Davi in that little picture. So we have the structures functions where he can put in there some exercises, some case tests, and in our case, the students can code there and they can get feedback from there. These are the screenshots. So online judges are tools. Just one second. Online judges are tools that support teaching and learning. So they give support to teachers and learners. And we have advantages with that. They are auto-graders. So students are coding there and they immediately get the grades. So they don't have to wait for us to give some feedback. They don't have to wait for another person to take a look and say, it's okay, it's not. So it's an auto-grader. Another positive impact is that it reduces instructors' workload. So if you think you have a class with 50 or 100 students and we have to assess, evaluate all these codes, it's a lot of work. And with these systems, we can reduce that. We have one point that's not so positive, that feedback's only based on correctness. It's right or wrong, or half right, half wrong. So it's not enhanced like we would like to have. And online judges are different types of web applications. The data that we collect are tests and submissions, error messages, and the whole code development process. So it gives us a lot of opportunities of learning analytics. We have a lot of data. And which kind of data? Oh, before that, So we collect this data. We have a kind of huge database and it's open. The address is there. So we have data collected from 2016. And as you see, we have a lot of students and a lot of code in this data set. So it's also a good opportunity for collaboration. Okay, and which kind of data do we collect? We collect, if you see this pyramid, we collect data from test codes and submissions to keystrokes. So every key that is pressed is collected and recorded in our log. Some screenshots of the log, so every key pressed, the submission that the student did, some assignments, so all the exercises that we provide are there and we have information about them. So as you see, we can have a lot of information, and also imagine if you have an AI course, you could have this same kind of information too, and this information could lead you to some knowledge. So usually in learning analytics, we do have the data and we get the information. And how do we provide feedback for the student or for the instructors? We usually have dashboards. And what do we do? What can we answer with these dashboards? So we put here some questions that we want to answer, like which students are struggling with this topic? What are the best exercise for each student? Can we personalize it? What aspects does the student need to improve to do well in the discipline? Which students are cheating, just copying and pasting? So would that be possible to answer? Would it be possible to answer this question using the logs? So we started a few years ago with my PhD student, Felipe, trying to come up with a programming profile. So which kind of features are important to kind of describe the programming profiles? So he, after a very deep literature review, he came up with 22 features that kind of describe this programming profile. Right now we have another PhD, that's Flavio, that's trying to come up with some new features, some more updated features. So the idea is that can we have an idea of what kind of behaviors, characteristics, features can tell us about the student, the programming student? So Felipe, for example, he found out 3 clusters. And as you can see, cluster A is more effective students, and cluster C is more ineffective students. And you can see in this graph, in this diagram, this graph, the difference between behaviors. So, and it's not like a rule, okay? It's the results that came up from our data set, from our context. But in our context, students that do many copy and paste, more copy and paste than others, maybe they could be in an ineffective group, okay? And this one, for example, the student that has a lot of lines of codes, maybe he's gonna be in a cluster that's effective group. So the instructor could kind of rational this. Okay, I'm looking at Kyle, specifically Kyle, a student. Where is he comparing to the group? Oh, okay, he looks good. He'll have a good performance. Okay, let's keep this way. Could be another one. A student that's not doing well comparing to the group. What can we do to do that? So I'm going to show you some cases like this, always looking at the data and trying to bring it to the instructor, to the teacher. How can he or she use this information to improve the teaching and learning? Or the student, he can take a look at his behavior and look and compare it to the class. And the comparison is like, okay, I'm doing this and the group is not doing this, do I have to change? Is this worth changing? I mean, just to have an idea of his position in the group. Okay, another important topic that we tried to figure out was if we have an idea of the performance prediction right in the beginning of the class, the course, could we do something with that? So we came up with an accuracy of 82.5% in the first 2 weeks of class. So if we know that a student is probably gonna fail, can we do something in advance to help this student? So see, this is something that may be interesting in computer science 1 or in other discipline. So the idea is, in this case, the class average is like 40% gonna pass this discipline. The prediction for Kyle is 80%. So can I suggest a group like, Kyle, can you help someone that's not doing so well? Can you pair program with him or her? So the idea is we have this information. Can we suggest something? Can the instructor suggest something? We also are interested in not just giving a number, just giving a raw recommendation. The idea is to give the information, but always also be transparent, explain it. Okay, you have the probability of this student to pass is this, but what is influencing this? So in this case, suppose Jose has a 15% chance of passing. What is influencing? Why is he getting this 15% chance? Oh, maybe he's copying and pasting too much. Can we talk to him and show some other strategies? His number of attempts is also influencing this. Can we suggest him to think a little bit more before attempting? Some suggestions, okay? Right now, because as we think about online judges, we think, oh, we don't have that much workload anymore. But on the other hand, we don't have that much contact with the students' codes as we use it to have. So we leave it to the system to evaluate. But so maybe sometimes we don't know what's going on in our classes. So the idea of this project is Rafael is doing this, is okay, in a group, in a class with many programs, can we identify some clusters, some strategies that the students are using, some approach, and group them, cluster them, and then this information will tell us about something. For example, if we say, don't use built-in functions, and as we analyze it, we see, oh, we have a group that is using the built-in functions, but we would like them to build their own, so we could have this information and do whatever we think is best for the class. Okay, another research that we try to do in our context is, okay, we have a lot of exercises, assignments, and for the teachers, it's usually always easy. So we see an exercise, oh, it's easy, piece of cake. But for the student, it's not. What is easy for us is not easy for the students. What easy for maybe Sweden is not easy for Manaus, for example. So the idea is, can we have an contextual classification of difficulty of programming exercises? I also mentioned about plagiarism, but it's a line of research that we have. We are also interested in emotion, especially in confusion and frustration, because we think it impacts on the learning. And I also have a PhD that's working with group formation, because it's really usual to have pair programming, for example, or we have an assignment and we have a group that do the assignment. So can we suggest better formations, better groups, so one can help another? And just to wrap up, coming back to learning analytics, I know I showed you a very specific context, development of an online judge. I know that's not easy. Not everyone can build an online judge. It's been like 10 years of development. But if you want to do learning analytics, I think you should first think, how can I collect data? Could it come from an LMS or for a website or for a form or I don't know. We should think, what can we measure? What do we want to measure? And we should analyze and, very important, report what we get. Report to the other instructors, report to the students. And also remember that, always remember, that learning analytics is about learning. So we are always worried and concerned about learning. Is learning happening? Is learning our main goal? And I think right now it's maybe the most important question we have with AI, for example. We're going to have AI to do many things for us, to be like our partner, learning partner. But are we learning? Are our students learning? Are they learning what is important? I mean, I've been doing these questions for myself, and it's really hard to answer. But maybe we could think about evaluation. Are we evaluating learning, or we are just grading? I mean, I have a lot of questions. Oh, for now, this is my talk. I'm really happy to be here, and thank you so much.
Thank you very much for that. Very interesting, and I fully agree with this last statement. I think that's really the key issue. We can get back to that in the discussion afterwards. Now, I would like to leave the floor to Professor Teresa Serrato Pagman from Stockholm University, who will talk about trustworthy learning analytics.
Thank you, Frederick. And I wonder if you see my slides?
Yes.
Yes, perfect. Thank you so much. Thank you so much for the invitation. I'm going to talk a little bit about the trustworthy learning analytics and artificial intelligence. And let me just check my, there you are here. And just for the audience, to better situate myself, as Frederick said, I'm a professor in human-computer interaction at the Stockholm University, but I have a background in cognitive psychology from Paris 8, and my undergraduate degrees as from University of Buenos Aires in Argentina. I'm leading a project about ethical and legal challenges with AI in higher education, and I'm also leading together with my colleague Olga Wiberg from the Royal Institute of Technology. We are leading this pedagogical development and learning analytics, which is this work package that Frederick presented when introducing the whole WASP AED program. So very briefly, I didn't know exactly, probably this is more for the audience, and as in connection with what Elaine has said, learning analytics is a field in at the same time as a set of systems, right? And the field has been developing from 2010. And when it comes to these different systems, we can classify them into descriptive or diagnostic, just showing, representing information in the dashboard. But also some of them include machine learning techniques and models like prescriptive analytics or predictive analytics. So basically, those are systems that help us to go, from representing information about the students to try to create pedagogical interventions to optimize learning. So what is new is not that the systems collect data, but what is new is that we design pedagogical interventions based on the data that is collected. So for this talk, I'm going to talk about learning analytics and artificial intelligence, AI, ED. So both, right? Even though there are specificities. And I'm going to start saying that there are many promises with these systems, identifying students at risk, helping those to pick up careers, advising services, improving the quality and value of the learning experience, developing adaptive learning courseware, personalizing learning, supporting self-regulated learning, and so on and so on. Some of these systems have been presented now by Elaine. And that is very good, and there is an enormous potential for these systems to really make a change and a big impact in the educational system. But at the same time, these promises bring new challenges. And I'm sure that this is not new for you in Brazil. There have been different problems with, especially with machine learning, with AI, face recognition, reinforcing bias in university admissions. There were public debates about what are we doing? Are we tracking their students? Is it clever? Is it creepy? And a lively discussion about the use of ChatGPT. So these challenges are in one way speaking about ethical considerations, or what we call responsible AI in education, which I think that boil down to issues of trust. So a little note about trust. So trust is, we all know, as a crucial element for the social cohesion, something that is in the political landscape we are living today, something that is crucial. It matters both in interpersonal relationships, but also trust matters when people relate with technology. To trust the technologies they use, this is something that is also fundamental. There is also trust in the relationship that we have with public institutions. There is what we call a moral capital, which is quite high, for example, in the Nordic countries, when you interact with public institutions. And it also is recognized as a critical aspect for AI adoption and usage, as I said before, to trust the technologies we use. So the question, or one of the questions that we can think about is, how do we cultivate trust in AI in education today? And coming from the Nordic, or having a Nordic perspective, being situated in Europe, when we talk about trust, most of the time we talk about this comprehensive legal framework that is called AI Act, which is a little bit different. I'm not sure what is going on in South America right now with the use of AI, but here in Europe is highly regulated. We have a very strong regulatory framework, and we have ethics guidelines for trustworthy AI. We have the General Data Protection Regulation, the GDPR, proposal for that Data Act, and then universities, institutions have their own ethical guidelines and principles and codes of practice. And that is, that's very important. That's the law. That is a way to care for the people. But at the same time, we know that principles alone cannot guarantee the ethical use of AI. So in our work, we distinguish, and we said that there are two different strands when it comes to ethical AI in education. One that is looking at the procedural elements of data management, the ethics of the data, what we call the ethics of justice, and all this whole framework, regulatory framework, which is fundamental. But there is another strand that is focusing on thinking about AI in education as a moral practice. So this is the other leg, I would say, of trustworthy AI in education that seeks to understand where should and should not use AI, where we want to deploy AI and why, which is connected to what we call ethics of care. So it's important to remember that these two strands go together. But the first one is the most developed at the moment. We don't know so much about the other one because it's a little bit more, it's not so concrete. It's much more abstract. So there's a lack of research on ethical, responsible, trustworthy AI in practice. We don't know so much about how these specific AI ethical guidelines are adapted or implemented or enacted in practice. And there is few evidence-based research studies examining teachers' trust in AI ED. So I'm going to briefly introduce you to 3 empirical studies that we have conducted with our group. And those studies have to do with these ethical and legal implications of using AI in higher education. So the first one is a experimental philosophical study. It's actually a survey that we conducted in one of the largest universities in Sweden. And we wanted to understand what would make university teachers willing to change their everyday practices to integrate AI into their teaching. And so the survey exposed their respondents to different scenarios, different cases, where we presented a case where we asked a bunch of questions in relationship to, well, look, in this scenario, you have a student which is a first generation student. That means that nobody in the family has been attending university before. The second one was an archetypical student, like a mainstream student. And this third one was a student with a learning disability. And what we found was that across all these cases, most of the respondents indicated that, of course, universities had a responsibility to use the tools we can to optimize learning. However, in the case of first generation student and the student with disability, the respondents indicated that universities should use AI for equity purposes to achieve equitable outcomes. So, so that is a way to say that the teachers were willing to put more time to learn how to use learning analytics and to develop competence in using it if it was going to use to increase equity in the system. So takeaways from this particular study in relationship to the question, okay, how we cultivate trustworthy AI? Well, some prompts or some elements to think about this question is we cultivate trustworthy AI contributing to equity in the higher university system, to think about how we include people that are at the margins of the educational system nowadays, and then generating a discourse that is counterbalancing this mainstream discourse on using AI to only optimize learning or enhance performance. So the second study that I'm going to present was inspired by the Turing test. Was an experimental study where we also conducted focus groups, and that was a study that sought to understand how do large language models impact university teachers' assessment practices. And we were interested in understanding the teachers' perceptions from the students' texts and in their assessment with the presence of ChatGPT in society. So more specifically, what we asked the teachers was to participate in this experiment where they blindly assessed student and ChatGPT written responses to whole examination questions. So, so they were assessing text. There were all of them generated by ChatGPT, but there were three instances. So there was one that was exactly the response given by ChatGPT. A second one that was a little bit manipulated by the research team, and the third one that was much more manipulated. So what we found out and this experiment was that the teachers became much more critical towards the students' written text. We were making a comparison with the grades that they were given before. We use real exams, so we could make the comparison, and they were downgrading, sometimes failing, and rarely awarded a high degree. So setting higher standards, and they were talking about this this feeling of being trouble, or these perceptions being a little bit more like not trusting what they were reading, because they weren't sure if it was written by ChatGPT or by the students. Yeah, takeaways from this study. So how do we cultivate trustworthy AI, Dan, with the presence of these large language models in society? Well, in the focus groups, it was very clear. Teachers were talking about, well, we need to absolutely face the presence of these large language models in a critical way and in a creative way. So not informing the students, helping the students to use these tools, not in a consumer mode or in a master mode, like oh, give me the answer to that, but critically and creatively understanding that the responses you get are not probably facts, or they're not the right ones, that these tools can hallucinate, that you have to double check, discuss, and confirm the information with other sources. So investing in tasks that are aimed to develop students' critical thinking and writing competences, and informing them about the difference between what is perform and what is develop yourself. Sometimes they go together, but sometimes you can be performing, getting a good grade without developing yourself, and that can have a serious consequence on the development of competence. The third and last study is a multi-stakeholder study where we conducted focus groups and interviews, and that was something that was very related to Elaine's online judge, because we were interested in understanding a little bit more the development of automated grading systems. There are different types of automating scoring systems, grading systems. They are being developed in Sweden, in Swedish universities. So we wanted to understand this a multi-holder perspective of the design of the systems. And for that, we target teachers, developers, people working with exams, administrations, students, to try to see how they perceive what is a responsible design and use of these systems. So we conducted a workshop with them, and in 3 phases. The first one was to try to understand the perceptions that they have about the responsibility with AGS, assessing a student's assignments. Then we ask them to write scenarios about what is an unresponsible use of AGS. And finally, we ask them to identify characteristics of what is a responsible design and use of AGS. And there are many things that I can tell you about this study, but let me just tell you about these highlights. So we understood that there's different stakeholders were talking about a contextualized responsibility, a situated responsibility. I mean, it's difficult to talk about responsibility in general. I mean, we need to understand that responsibility is really situated, attached to a particular task, a particular exam in a particular program, right? It's a shared responsibility, and it's a responsibility that is not, at the beginning or at the end, is continuous. It's a responsibility that is present before, during, and after the design of the AGS, or at least they say they should be that way. We understood that they were also talking about, on the one hand, this push for objectivity and efficiency. Many of the teachers we were interviewing were developing themselves this AGS because, of course, they want to save time. They want to also ensure consistency in the grading. And those are teachers teaching large classes, and we are talking about more than 300 students. So there was this push for efficiency and objectivity, but at the same time, there were concerns about, well, but what's going on with this individualized learning experience, and this that Ellen touched upon, this, losing touch from what's going on with the students and trying to understand what the unique needs are. Another thing that I think is interesting to highlight is that the teachers were talking about these responsibilities they have as a state representatives. So we are talking about public universities. And in Sweden, as when you work for the state, you have this, you are representing the state. So you must uphold these public values, trust, and fairness. So what happens is that when the systems, and when you don't understand exactly how the system propose a grade or a recommendation for a grade, there is what we call this emotional burden. The teachers felt, saying that, well, we are representing the state, but then we have a duty to understand and be able to give a clear explanation to the students about the grades they get. Finally, teachers often do not have the final say when these systems are adopted and implemented in practice. So some of the takeaways from this study is that, okay, how do we cultivate trustworthy AI or AGS? Establishing and maintaining meaningful relationships between these different stakeholders during the whole process, from before the design, during the design, and after the design, making the process more participatory. I think that Seyi was saying something about that. We need to change the way in which we design our development practices, well, participatory design has a huge place or a huge role to play here. Negotiating trade-offs. I mean, having conversations about these trade-offs that were very clear between efficiency, performance versus taking care of the self-development of the students. Sometimes you create a exam because you can use the AGS, and you are validating knowledge or skills that the system can do it, but probably it's not necessarily the skills and knowledge that you want to validate as a teacher. There are some gaps there. There is much work to be done. And then this interesting insight about cultivating a sense of doing the right thing and not only doing things right. And that goes back to these two legs that I presented before, the ethics of the data, and then understanding that we are exercising a moral practice in education. It's not only, doing things right with the students' data, that's important, but also thinking that what is the right thing to do in this situation. So finally, some general insights, and I think that they are quite general, but perhaps we can have a discussion around them, as these three studies are telling us or giving us some elements of how to think about cultivating trustworthy AI in higher education. And one of the things that are important to understand is that, as Frederick said, Seyi and Elaine, I mean, we have AI as an unprecedented technology development. Is a very powerful tool that we need to balance with a solid growth of what is called professional collective judgment. So we need to exercise this judgment, right? This way to judge situations, to understand that there are many things we don't know, and there are many things that we are experimenting with this technology. So in order to unleash the potential or harness the potential of AI, we need to really develop this muscle that has to do with this professional collective judgment. That means that we need to talk about and negotiate and talk about these nitty-gritty cases that we don't know exactly what to do. I think that I'm gonna stop here because I think that the time is up. And thank you very much to the group, and yeah, happy to continue the conversation.
Thank you very much. So we have a couple of minutes before the hour here, but I would like to ask the audience if you have any questions, please type them in the chat and we would be happy to take them up. So I wanted to ask you a question, Therese. I mean, we had this question in chat before. I mean, how do we kind of make sure that students learn not the shallow kind of knowledge, but actually get this more deeper knowledge that we're after? And I'm curious, I mean, based on your studies and your research, do you have any insights to share regarding that topic?
Yeah, I mean, what is the thing that you mean by shallow knowledge? What is
So
the
basically that they're just using the tools without learning anything themselves.
Exactly.
So basically
Right.
it's about this
Yeah.
replacing the human learning with just using tools.
Yeah, exactly. Thank you, Frederick. Absolutely. I think that we have mentioned that before. We have talked about that before, which is critical thinking. So how we cultivate critical thinking among the students. I think that nowadays, based on what we have seen, I mean, this is a powerful technology that is transforming how people, how people do everything, right, in society. So the counterpart of that is to develop thinkers, people who are able to judge situations, to reason in a situation without exactly knowing what's going on, without, or be able to reason with the proposition of a system that is coming up with a recommendation for you to make a decision. So if this judgment is, which we go back to the humanities, right? Social sciences, philosophy. I think that is very important to infuse today in our programs, and that could be very simple. From asking the students why you are doing that, how you are doing that, show me, tell me, making them participate in groups, giving them the responsibility to teach others. I mean, there are plenty of ways to understand how they can critically look at the system, and so they are not, as you said, consuming, right, or just mastering, the system. Oh yes, Siri, give me the answer to that, and then pasting that. So I think that's important. I think there is a huge risk also. We talk about the students, but we have different types of students, and students being at the margin of the educational system. I think that there is a risk for them to performing, looking, and using AI for performing, and forgetting that if they are not developing themselves, they will be really in trouble in the future. As an educator, as a teacher, I feel a lot of responsibility to, help specifically these students to open their eyes and do this job of helping them to think about the systems that they are using.
Thank you.
I
So,
think
Professor, yes, please, Elaine, go ahead.
I think we are in an era that we have to rethink everything, rethink definitions. What is shallow? What is shallow, and for whom is it shallow? I mean, we use computers, but we don't have to really know about circuits, electric circuits. We don't have to. We have to know how to use it. I think it's an era where we and our students have to think who I want to be, how can I do the right things? I think that's a very important question. How can I help help others? I mean, and it's so hard for me because it's not just about computer science or AI, it's about living in this diverse world, hybrid world. I don't have the answers, sorry.
But we have questions.
Questions, many questions.
And I think that's also important. I mean, I really like your comments here that, I mean, we have to rethink. I mean, you say what is shallow. So, for example, what if I can now do these activities with the tool? Maybe I am capable of doing things, but I might not need to know everything myself.
Yes.
And I think that is kind of putting challenges on the kind of educational system, and also to rethink what we need to learn, but also what we need to teach. Because I mean, also I completely agree with Teresa. I mean, we want to empower the people. I mean, that's the point of education, empowerment, not just to take some quizzes and get a piece of paper, but really how do we prepare them for the future.
Because at the same time, we don't want them to be anxious about this. I think in my point of view, we want a lighter world. I mean, everyone could do something and it would be a better world. Not, I have to do everything, I have to learn everything, I have to know everything, I have to have all the answers. That's not the idea, I think, right now.
So, thank you very much. So, unfortunately, our time is up here. So I would like to thank you both for excellent presentations and some discussions. I would have liked to continue, but we will do that another time. So there was a question about the presentations. So if you're willing to share your presentations, please send them to Eva-Lena, and then we can put them onto the event webpage. So I think that would be very happy. So thank you all for both the panelists and the audience. So thank you very much and have a nice afternoon or day or evening. See you.
Thank you so much.